Hi, Chris Kuzmal here. I wanted to go back and talk a little bit more about existential distribution and use my lovely green box illustration, which actually makes much more sense when we're talking about existential distribution than when we're talking about common quantifier reversal. I believe that's what I had in mind when I created the animation, but I lost track of what I was trying to say. So here we have our existential distribution action, as it were. On the left-hand side, we have a black sentence, there exists an x for all y, blue of x implies q of y. And on the right, we have for all y, there exists an x, blue of x implies q of y. And then we ground both sentences on the left and the right. And the question is sort of why are they equivalent, and kind of why can I go one direction and not the other? So again, we emphasize this first class where we have two logical sentences: blue of cat implies cute of cat, and blue of cat implies cute of ball. We have to have both of those logical sentences evaluate to true in order to cause the black sentence to evaluate to true, unless the other clause evaluates to true. But we need one of them, one of these two to evaluate to true. And for one of them, for the first one to evaluate to true, both of the portions, the blue cat implies cute cat and the blue cat implies cute ball, both of those have to be true. Each of those logical sentences or clauses, if you will, gets distributed across two different clauses, if you will, in the purple sentence. And when they do that, they within the context of each one of the sentences they're in, and in the distributed case, they're all that's necessary to cause the logical sentence for that portion to evaluate to true. And so as a result, one intuitive way of putting it is that the green has to be true here, the green has to be true here. The green is there in both cases, the same amount of green, sort of intuitively speaking, and that's sort of what makes it so that existential distribution it works. But the green kind of can only kind of split up, it can't recombine. Again, that's more of an intuitive explanation for why existential distribution works one direction but not the other. You can't do universal distribution across an existential quantifier. Okay, so meanwhile, we need to talk a little bit about negation distribution. I believe this is De Morgan's law. I don't hope I'm not getting it backwards, but it's a generalization of it. We take that negation symbol in front of a logical sentence, and we can move it inside of inside of the universal quantifier if we change the universal quantifier into an existential quantifier. That's fundamentally all we have to do. It's actually a very mechanically simple thing to do, and the grounded version of it is just an expression of De Morgan's law, complete with an extra closed parentheses here. Sorry about that. I guess the reason I had this extra closed parentheses is because I no longer needed these parentheses here, and I sort of overlooked. Or actually, I don't want this closed parentheses over here either. So that's just an extra closed parentheses that shouldn't be there. Now, let's see if we have time to talk about translating relational logical sentences into propositional logical sentences. So we can treat relational logical sentences in the same way as propositional logical sentences. We can classify them as unsatisfiable or contingent or valid, and they can relate to one another in exactly the same way as propositional logical sentences through equivalence, consistency, and entailment. And fundamentally, relational logic is identical to propositional logic in terms of these higher level concepts. As long as we can kind of demonstrate that by saying that in general, you can take any relational logical sentence, such as this example here, and we can translate it by grounding it and transforming. So that gets rid of the quantifiers of the for all x and for all y go away because we grounded it. And then the relations can be replaced with proposition constants. And so the bottom sentence is a completely a purely propositional logic sentence that has the exact same semantics as the propositional logical sentence above. Thus, all those properties, unsatisfiable, contingent, validity, equivalence, consistency, and entailment, all apply to relational logical sentences just as well as propositional logical sentences.